Check, check. Hello, check. Hi. Check. Yeah, கேக்குது. Fine. Hello, hello. Come on, Ricky Jones. உங்க ஃப்ரெண்ட்ஸ் எல்லாத்தையும் இந்த வீடியோ இந்த லிங்க் ஷேர் பண்ணி ask them to join. Hi, Safura. Hi, Ria. Hello, hello, hi. Hello, everyone. Chatல அவ்வளோதான் எனர்ஜியா? Just 3 people. Okay. In a class, it's super easy, simple. Okay, I love this chapter. It's like very not super difficult knowledge. Or a simple and basic understanding if you have on the concept now, you can solve any type of question. அது அந்த மாதிரி one chapter. Yeah, very few chapters like this. Okay, you can't do the same with solids and all. I mean fluids. The mechanical property of solids. Yeah, it will start இன்னும் கொஞ்ச நேரத்தில். Okay. Before starting the class, yeah, எல்லா செஷனும் பண்ணிட்டுருக்கோம். இந்த செஷனும் பண்ணுவோம். Okay, ask me your doubts related to your preparation. Okay, NEET 2026 ஓட preparation base பண்ணி still you have like 2 full months. Okay, so அந்த 2 full months எப்படி பக்காவாக capitalize பண்ணுவோம், how in where you are lagging, if you want some help. Okay, just let me know in the comments. I'll try to reply to almost all. இல்லை எல்லாத்துக்கும் ரிப்ளை பண்ணிடலாம். ஓகே, okay. How to revise 11th? Many chapters are weak. Many chapters are weak. Okay, So you are struggling with 11 syllabus இப்போ done, it's fine. You have 2 months time, okay? You know that. என்னை விட உங்களுக்கு நல்லாவே தெரியும் எவ்வளோ நாள் இருக்குன்ட்டு. You would have known till hours, minutes, seconds அளவுக்கு உங்களுக்கு இது டைம் போகிறது நல்லாவே தெரியும், ஓகே? பட் நவ் okay, but now you have two months la, okay? You have 2 months. 2 months la first analyze எந்த சப்ஜெக்டில் you are lagging ப்ராப்பர்ல, இதில் வந்து you are lagging a lot அந்த மாதிரி. பிகாஸ் if you lag பயாலஜிலனா அது வந்து உங்கள் டோட்டலாக பயங்கரமாக அஃபெக்ட் பண்ணும். பிகாஸ் 360 மார்க்ஸ் கம்ஸ் எல்லாம் வந்து 180 அரௌண்ட் 180 to 190 மார்க்ஸ் வந்து 11 சிலபஸ்லேருந்து மட்டும் வரும், ஓகே? அவுட் ஆஃப் 316 பயோ. ப்ரோ ஹெட் பெயின் அதிகமாக இருக்குது ப்ரோ. ஓகே, பிஃபோர் தட் சி அதான் பயாலஜி லைஃப் யூ ஆர் வீக்னா மேக் ஷுர் தட் யூ ரீட் எவ்ரி திங், ஓகே? எல்லாத்தையும் தரோவாக்குங்க. மேக் ஷுர் யூ டூ தட், ஓகே? இஃப் யூ ஆர் வீக் இன் ஃபிசிக்ஸ் அண்ட் கெமிஸ்ட்ரி, ஓகே, சாப்டரில் இருக்கிற important models and important questions in the time you can't solve like 200 questions and all if you are weak, okay? Better solve as much questions as possible so that you cover almost all the major topics. மைனரா குட்டி குட்டியாக கொஞ்சம் கொஞ்சமாக இருக்கும், அதெல்லாம் விட்டுருங்க, இப்போதைக்கு வேணாம். ஆல் மேஜர் டாபிக்ஸ் உங்களுக்கே பார்த்தா தெரியும், திஸ் இஸ் இம்பார்ட்டண்ட், இது இந்த இம்பார்ட்டண்ட் அந்த மாதிரிலாம், ஓகே? சில மெக்கானிக்ஸ் எல்லாம் வந்து எல்லாமே இம்பார்ட்டன்ட் இன் 11th, ஓகே? I have videos uploaded in this channel. If you want, check it out. Mechanics எல்லாமே இன்னும் போயிட்டுருக்கு. So yeah, it depends on where you are lagging. If you lag in biology na நீங்கள் ஃபுல்லாக படிக்குங்க, படிச்சு தான் ஆகணும். If you lag in physics chemistry na try to cover only the important ones, okay? அதுக்கு மேலே போக அவசியம் இல்லை. Because if you cover the important topics மட்டுமே வந்து it will be super sufficient. Yeah. ஏன்னா இந்த டைமில் யூ காண்ட் லேர்ன் மோர் தென் தட். ஸ்டில் யூ ஹேவ் 2 months. இஃப் யூ ஆர் ஏபிள் டு நா சால்வ் எவ்ரி திங், ஓகே? சால்வ் ஆல் மாடல்ஸ், ஆல் ஃபார்முலாஸ், ஜஸ்ட் நோ எவ்ரி திங். Because if you were not able to now, try to focus on all the major topics and all the major usually repeated models of questions, okay? How you got 775 in physics? எனக்கு ஆவரேஜ் 150 தான் வந்து. ஏன் 175 வந்துச்சுன்னா, ஒரு கொஷின் வந்து ஆட்டம்ஸ்லேருந்து ஒரு கொஷின் கேட்டிருந்தாங்க. இட் ஹேட் ஒன் ஆப்ஷன் கரெக்டாக, அதுக்கப்புறம் தி சேஞ்ச் தி ஆப்ஷன், ஸோ ஐ காட் 175. ஆவரேஜ் 150 தான் வருது. 150 இஸ் டீசென்ட், நைஸ் ஆவரேஜ். எனக்கும் அவ்வளோதான் இருந்திருக்கு, ஓகே? போக போக when I started solving grand tests, அதுக்கப்புறம் ஃபுல் பார்ட் டெஸ்ட், இந்த மாதிரி போக 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 மை மார்க்ஸ் இம்ப்ரூவ்ட். பட் ஐ வாஸ் ஆவரேஜிங் அரௌண்ட் 160, 150 to 170 ஸ்கூலரை நம்ம ஃப்ளக்சுவேட் ஆகிட்டே இருக்கும். இன் தி எண்ட் போக போக யூ வில் கெட் மோர் ஸ்டேபிள் இன் தி ஹையர் ரேஞ்ச், ஓகே? டோன்ட் வரி. ஆல்சோ பேப்பர் டிஃபிகல்ட்டி, எங்கள் பேப்பர் வாஸ் ஈஸி, okay? 2025 was hard, so other based பண்ணி if they are giving you questions now, it will be time consuming, but still it's still possible, okay? Scoring 180 on such a difficult paper is also possible when you have had enough practice of that sort of questions, okay? Fine. What would be the expected cutoff எனக்கு தெரியல ப்ரோ. only God can predict. God தெரியல. Based on it depends on various factors, okay? ஒன்று வந்து depends on how many people attempt the exam. Another, how many people were able to answer it correctly, okay? If you want to know na average ranks will be same. ரேங்க் வந்து மாறாது. இந்த காலேஜ்க்கு இந்த ரேங்க்னா அந்த ரேங்க் தான் இருக்கும், அதுக்கு மேலே கொஞ்சம் மூவ் ஒரு 100 ரேங்க்ஸ் மேலே 100 ரேங்க்ஸ் கீழே போகலாம். பட் கட் ஆஃப் வந்து ஐ கான்ட் சே ப்ரோ. என்டிஏக்கே தெரியாது, கொஸ்டின் பேப்பர் ஃப்ரேம் பண்ண அவங்களுக்கே தெரியாது how it's going to end up, okay? So yeah, ப்ரோ ஹெட் பெயின் அதிகமாக இருக்குது ப்ரோ. டேக் சம் ரெஸ்ட், ரிலாக்ஸ் பண்ணுங்கள். ஸ்ட்ரெஸ்ஸால் வந்திருக்கலாம், ஓகே? ஆர் டீஹைட்ரேஷனாக இருக்கலாம். டேக் சம் வாட்டர், சால்ட், ஓகே, ஓஆர்எஸ். ஓகே, ஸோ அவ்வளோதான். திஸ் இஸ் ஆர் ஃபஸ்ட் முடிஞ்சு. இதுக்கு மேலே வேறு யாருக்காச்சும் டவுட்ஸ் இருக்கா பேஸ்ட் ஆன் யர் ப்ரிப்ரேஷன், ஹவு டு ப்ரோசஸ் அண்ணா அது என்ன ping me in the comments, okay? I will be in, YouTube streaming late, it's this little delay, so I will move to the streaming software. Apapa I'll come and check out. If you have any doubts, feel free, okay? Done. ஓகே, கிளாஸ் ஆரம்பிக்கலாமா? நிவாஸ் ப்ரோ, ஃபிசிக்ஸில் 105 மார்க்ஸ் தான் வருது, என்ன பண்ணுறது? ஓகே, this is one serious question, okay? See, 105 marks தான் வருதுன்னா, that means how many questions are right? 26 questions are right. Or அதை விட 30 question கரெக்டாக இருந்து, or it varies, okay? You might have 25 to 26 questions you are right வச்சுக்கலாம். மற்றெல்லாம் நீங்கள் வந்து எழுதலை, நெகட்டிவ் மார்க்கிங்ஸ் இல்லாமல். ஓகே, ஃபைன். இப்போ வந்து you have no, then it means that you have no clue about the remaining, say the bare minimum you have to solve 25 questions. இல்ல அதுக்கு மேலே சால்வ் பண்ணி நெகட்டிவ் மார்க் ஆகிருக்கலாம். பட் லெட்ஸ் டேக் 26 questions நீ சால்வ் பண்ணிக்குது. ஓகே, இந்த 26 question நீ சால்வ் பண்ணிக்கன்னா இதில் வந்து ஆல் ரைட். ஓகே, இதை தாண்டி யூ ஹாவ் 19 questions மோரா. ஆப்வியஸ்லி இந்த 19 questions நீ ஏன் அட்டென்ட் பண்ணல, ஆர் ஏன் தப்பாக போச்சு, யூ ஹேவ் டு அனலைஸ் இட். அனலைஸ் பண்ணால் மட்டும்தான் வந்து யூ வில் பி ஏபிள் டு ரெக்டிஃபை யர் மிஸ்டேக்ஸ். ஓகே, வென் யூ அனலைஸ் இட் எப்படி பண்ணணும்னா, ஃபஸ்ட்டு படி, இஃப் யூ ஹேவ் எனி ஐடியா ஆஃப் தி கான்செப்ட், ட்ரை சால்விங் இட் ஆன் யர் ஓன். ஓகே, எக்ஸாமில் டைம் இல்லாமல் போயிருக்கலாம். வென் யூ டிட், அப்போது உனக்கு டைம் இருந்துச்சு, டைம் இல்லாமல் போனதால் யூ ஆர் நாட் ஏபிள் டு சால்வ். பட் இஃப் யூ நியூ த கான்செப்ட்னா இட்ஸ் ஃபைன். பட் இஃப் யூ டோன்ட் நோ த கான்செப்ட், ஓகே, அப்போ வந்து யூ ஹேவ் டு ரிவைஸ் த கான்செப்ட். ஓகே, நோ அண்டர்ஸ்டாண்ட். சி இன் ஃபிசிக்ஸ் இட்ஸ் லைக் இட்ஸ் just 3 things. ஓகே, பேசிக்லி you have concept. ஓகே, இதான் உன்னோட லேர்னிங் அப்ரோச். லேர்னிங் இது பேஸ் பண்ணி தான் இருக்கணும். யூ ஹேவ் கான்செப்ட், அண்ட் தென் அது பேஸ் பண்ணி யூ வில் ஹேவ் சர்டன் ஃபார்முலாஸ் which come from derivation, and the formula you will apply in questions. Super simple. Okay, either you would have made mistake in the concept, or you would have made mistake in the formula, or you would have made mistake in the application of the formula. Okay, இந்த மூணில் எங்கே நீ மிஸ்டேக் பண்ணேன்ட்டு ஐடென்டிஃபை பண்ணி rectify that. Okay, it would have been a silly calculation mistake which comes in under this formula to question part, application part. It might have been a simple sign change which நீ formula தப்பா போட்டிருக்கலாம், so it comes in this formula part. It might have been entirely different formula which you weren't supposed to use, concept based. Okay, இந்த மாதிரி கேட்டகரைஸ் பண்ணி உங்கள் மிஸ்டேக்ஸை correct it. Okay, and write it down in a note. Okay, எங்களுக்கு இன்ஸ்டியூட்டில் they call it error notes. எல்லாத்துக்கும் சொல்லுவாங்க error notes. இட்ஸ் ஸோ இம்பார்ட்டண்ட். ஓகே, நீ வந்து எல்லாமே கரெக்டாக பண்ணியிருந்தாலும் நான் எங்கள் செட்டில் வந்து we had optional questions. Sometime those optional questions நான் ஸ்கிப் பண்ணியிருப்பேன், நான் படிக்காமல் விட்டுருப்பேன், அண்ட் அது I wouldn't have been able to solve. அது எப்போ ரியலைஸ் பண்ணேன்னா when my teacher, okay, he was like ella nee ena question la vittiyo, solve and show me all those questions, and I was not able to. Okay, from then on I started using this error notes. அதில் வந்து நான் என்னோட சாய்ஸ் கொஷின்ஸ் எல்லாம் நான் எழுதியிருப்பேன். along with that whatever questions I made mistakes அதையும் I would have written. I would have என்ன என்ன இது பேஸ் வச்சு இந்த கொஷின் ஃப்ரேம் பண்ணியிருக்காங்க, I would try to understand and apply the formula as well. Okay, so that's how you should correct your mistakes. Okay, Nivas. கேட்குறாங்கன்னே தெரியவே டைம் ஆகுது. சம்டைம்ஸ் அந்த மாதிரி இருக்கும். ரீசன் பீயிங் எக்ஸாம் ப்ரெஷர். வென் நீ வந்து அதுக்கப்புறம் ஃப்ரீயாக வந்து உட்காரும்போது இஃப் யூர் ஏபிள் டு சால்வ்னா அப்புறம் உனக்கு கான்செப்ட் தெரியும். பட் உங்களுக்கு எக்ஸாமில் டைம் கன்ஸ்டன்ட் இல்லாமலேயும் யூ ஆர் நாட் ஏபிள் டு ஐடென்டிஃபை தட்னா அப்புறம் எனக்கு கான்செப்ட் தெரியலன்னு அர்த்தம். ஓகே, அப்போ வந்து யூ ஹாவ் டு emphasize on studying stuff. Okay, ஆனால் எக்ஸாம் ப்ரெஷரில் you are not able to solve. ஆனால் after exam you are able to solve na, you have to familiarize yourself with the அந்த environment, examination ஓட environment. Okay, அந்த டைம் கன்ஸ்ட்ரெயின்ட் இருக்கிற ஒரு என்வாயர்மெண்ட்டில் you have to practice a lot so that you will be able to solve faster, you will be able to understand the question faster. If you see சில கொஷின்லாம் உங்களுக்கு எல்லாருக்குமே தெரியும், நீ வந்து எக்ஸாமில் சால்வ் பண்ண முடியாது, and you will be able to solve in class, I mean after examination. Reason being exam time constraint, pressure இருந்துச்சு, I was not able to solve. So make yourself used to that pressure. Okay, that will actually help in and understanding the question fast. It will improve your speed. Okay, because it's like a race against them. You have 180 questions and you have 180 minutes. So yeah, நீ டைம் கொஞ்சம் கம்மியாக தான் இருக்குது. நீங்கள் you have to practice it. See, because நான் வந்து I wrote JEE mains as well. Okay, அதில் வந்து it was like I solved entire physics and chemistry. I didn't know maths. ஏன்னா நான் மேக்ஸ் நான் செலக்ட் பண்ணேன். I didn't know maths. I was able to solve the entire physics and chemistry again. Okay, so like 25 questions, 50 questions here. I solved it in 1.5 hours. I solved the entire thing again in another 1.5 hours. So அந்த மாதிரி you can't do in NEET. Okay, so first time you have to get the right thing. அந்த மாதிரி நான் செகண்ட் டைம் சால்வ் பண்ணும்போது there was a few mistakes which I corrected as well. Yeah, and since it was computer based என்னால் மாற்ற முடியும். But NEET is not like that. Okay, so familiarize yourself in this environment and also practice a lot in the time constraint oda in the pressure oda try solving more, because when you first time paakumbodhu you must get what the question is trying to get answer from you. Okay, அதான். ஸோ யா, இதுக்கு மேலே நான் பேச விரும்பல. இஃப் யூ ஹேவ் எனி டவுட்ஸ் அதான் லைவ் கமெண்ட்ஸில் சொல்லுங்கள். யா ப்ரோ, இதுதான் சில கொஷின் வீட்டுக்கு வந்து சால்வ் பண்ணால் வருது. யா சரி, ஓகே, கமெண்ட்ஸை சொல்லுங்கள். லெட்ஸ் ஸ்டார்ட் வித் லெக்சர். இப்போ this is mechanical properties of solids. Okay, I am Mohammad Rihan from Madras Medical College, second year MBBS. So yeah, this is our beautiful team, Vidamuyarchi 2.0 crash course. Okay, all these people are going to take classes for you every day at 6:30 and the every evening they'll be live. Sunday you have 2 classes in the afternoon and the evening as well. Yeah, and we have an application on Play Store. Okay, SNG test series. இதில் வந்து you have chapter wise questions. Okay, and then you have unit wise questions, and then you have 15 grand tests. Okay, அதுவும் போக whatever lecture notes I'm writing here, அதோட link along with the notes will be uploaded in the app. Okay, everything just for 500 rupees. And you also have MCQ worksheets available on the app daily. Okay, you can solve it. Yeah, Okay, done. Properties of solids. Mechanical properties of solids. Okay, because mechanical ரொம்ப பெருசா இருந்துச்சு, so I wrote properties of solids. Okay, it's a very simple chapter, a small one as well. I'll finish it very easily. Okay. Okay, let's start. Now, interatomic forces. Okay, or atomic something, whatever you call it. See, there are forces. இது வந்து இங்கேருந்து ஒரு கதை மாதிரி எடுத்துட்டு போங்க. ஓகே, இட்ஸ் சிம்பிள். ஓகே, ஜஸ்ட் ஒரு சின்ன கதை. பிகாஸ் இந்த சாப்டரோட ஸ்டார்டிங் ஃபார் அண்டர்ஸ்டாண்டிங் சிக் இட் ஹாஸ் ஃபியூ ஸ்டோரிஸ். ஓகே, அதை மாதிரி வச்சு ஞாபகம் வச்சுக்கோங்க. கொஷின்ஸ் won't be based on this. Okay, fine. Interatomic forces. See, when there are attractive forces, okay, in nature which bind atoms together. Okay, there are so many atoms everywhere. Okay, இந்த atom எல்லாம் வந்து through by means of attractive forces they are held together, right? Correct. Okay, when in gravitation we saw that attractive forces, yeah, அதோட magnitude of அதோட potential energy is taken as negative. Okay, because we considered that the object to be free from one's influence, it should be in infinity. அப்போ இன்ஃபினிட்டியில் we consider that influence to be 0. அப்போ பக்கத்தில் வர there is more influence and we consider it as negative. Okay, fine. And the other thing you have to remember is repulsive forces. அவங்க வந்து அதோட potential energy due to repulsive forces, they are taken as positive. Okay, all this will make more sense when you enter electrostatics. Okay, and the unit, if you உள்ள போனாலே வந்து you'll have clear idea about all this stuff. Okay, ஏன்னா அதில் வந்து you will have to find based on charge which you have to find potential energy of the system and all. So yeah, you'll understand. Okay, yeah, the 45 questions solve பண்ணா it will be sufficient. Okay, yeah, so is that clear? I'll go a little slow in the audio. Okay, I don't want to rush anything. Fine. I'll open the comments here because the streaming software கொஞ்சம் இங்கே ஓப்பனாக இருக்கு. Okay, all right, simple. Now consider an atom. Okay, okay, these are my two atoms, okay. This is my nucleus of one atom. This is my electron. This is my electron cloud of one atom. And this is my nucleus of one atom and the electron cloud of the other atom. So everyone knows basic atomic structure. Okay, this is how it is. A nucleus, it's positively charged because of protons, and electrons are negatively charged that are taken on the Mari, so positively charged. Okay, let's find the forces between the atoms. Okay, so what on the negative charge of my nucleus of one atom and the negative charge of the nucleus of the other atom, I mean of the negative charge of the other atom, they repel each other. Okay, this will repel each other, and you have another repulsive forces which are these are the peripheral irukadala they influence. Okay, you have attractive forces which is between this nucleus and my in the electron. Okay, attractive forces, and you also have other attractive forces. Okay, there are attractive force, and then you have repulsive forces between nucleus to nucleus. Okay, now I am depicting attractive forces with green. This is my attractive force, and repulsive forces with red. Okay, this is how the interaction between two atoms are. Okay. ஆனால் நீங்கள் டீச் பண்ண லெசனில் இருந்து எவ்வளோ கொஷின் எக்ஸ் பண்ணலாம். It depends on which chapter. In the chapter there won't be much questions. You'll have probably one or two. Okay, so okay, fine. இப்போ வந்து this attractive force இருக்கு இல்லையா, இது சௌமியா. ஓகே, இந்த attractive force இருக்கு இல்லையா, attractive forces அதோட force is proportional to 1 by r power 7, where r is the distance between them. Okay, so reduce the distance, more will be the force. Okay, and இது வந்து the repulsive forces will be force is proportional to 1 by r power 9. Okay, fine. For terminologies, I'll have one graph for you. இது வந்து நீங்கள் ஆட்டம்ஸ் சாப்டரில் பார்த்துருப்பீங்க கரெக்டாக, அண்ட் திரும்பி இன்னொரு வாட்டி ஆட்டம்ஸ் சாப்டரில் நீங்கள் பார்க்க போகிறீங்க, which I will be teaching. Okay, we all know for a system to be stable it should have the least possible energy. Okay, so if you take ஒரு ரெண்டு ஆட்டம் எடுத்துக்கோங்க, they bond together. Okay, they form a molecule because they want, okay, there is this tendency for them to get stable. Okay, when they're stable now they won't interact with others as well. Okay, and the stability கிடைக்கணும்னா they should have the least possible energy. Least possible energy இருக்கும்போது தான் வந்து they will be stable. Okay, fine. All right, so let's say this is my let's say force, let's go, or potential energy. Let's say this is my potential energy. அதாவது the energy due to the position of an object. Okay, my two atoms are close, then the rendu atoms oda position based poni they have some energy because of the charges with them, between them. Okay, charges in them. Fine. So potential energy whenever it is the least, okay, whenever it's the least, my atom will have the most stable position for it to be. Okay, fine. Let's see, octet rule la neenga padichirpinga, all is everything is based on getting stable, getting more stable, getting more stable. Okay, conjugation ellame. So let's see, this is my potential energy, this is my distance r. Okay, fine. The distance r, let's say our atom oda energy how it varies with distance r. Fine. The graph when plotted it goes something like this. To be more precise, it's something like this. Okay. Okay. In the graph, what does it signify? Oh, wait, it's so bad. Just give me a second. You get a graph similar to this one. Okay. This is my negative. This is my positive potential energy. See, whenever you come closer, okay, whenever two atoms interact closer, you find that there is some attraction between them. So when attraction is maximum, okay, அந்த பாயிண்ட்ல it will have least potential energy. Okay, அதுக்கப்புறம் this attractive forces, okay, it gradually decreases from in the point. And then repulsive forces between atoms. So more close you come, even friction la பார்த்திருப்போம், whenever we smoothen out the stuff இல்லையா, when surfaces it will get more smooth and the friction, the interlockings between them will decrease. Okay, coefficient of friction will decrease. ஆனா after some point it will start to increase because ரொம்ப flat ஆக the more smooth it gets, the more contact with the ground it will get. Okay, அப்போ வந்து there will be more interaction between atoms, because of which there will be more resistance, அதனால friction will increase. Okay, fine. Same here, ரொம்ப பக்கத்துல வந்ததுக்கு அப்புறம் there will be more repulsive forces. There will be more repulsive forces because of which the potential energy increases. Okay, now when the potential energy is this point, okay, இந்த பாயிண்ட்ல இருக்கும்போது தான் வந்து the atom is stable. Okay, the interaction between the two atoms is stable. Okay, so the atom tends to be in this position only. Okay, this is where my attraction is maximum. Okay, fine. Why did I tell you this graph? You'll get to know, because this is a question, the mechanical property of solid, yeah, you'll understand. Okay, okay, so you have no more doubts in that. Okay, fine. Okay, now there are few terminologies which you must know. Hi Anna, hi. Few terminologies. First terminology is deforming force. Simple. I just tell you the name which you can kandupidichala. Okay, there are few terminology which you must know. One is deforming force, and then you have rigid body. Deforming force is when a force causes deformation. Okay, deformation is nothing but the displacement of atoms within the body. Okay, so when you have a rubber வச்சுக்கோங்க rubber அமுத்தும் போது it shrinks. Okay, அதோட length changes, அதோட breadth changes, அதோட entire area changes. Okay, volume stays same, ஆனால் அதோட ஷேப் சேஞ்சஸ். ஓகே, அந்த ஷேப் சேஞ்ச் காஸ் பண்ணுற ஃபோர்ஸோட பேர் தான் வந்து டிஃபார்மேஷன் ஃபோர்ஸ். ஓகே, it causes deformity. Fine. See, when just imagine. Okay, just imagine எல்லாரும் I want all your attention here, all your attention on the screen இப்போ for just 1 minute. நல்லா கவனிச்சுக்கோங்க. See, now I have this deformation force. ஓகேவா, அண்ணா physics நான் ஒரே நிமிஷம் ஸ்ரீராம் 1 minute. ஓகே, see, atoms வந்து they are stable. Okay, நம்ம ரிலாக்ஸ்டாக கொண்டு இருக்கு. I'm emphasizing on the concept because this is the core idea behind which எல்லாமே works. Okay, so see, my atoms are in a ப்ராப்பரான ஒரு லீஸ்ட் பொட்டன்ஷியல் எனர்ஜி பொசிஷனில் இருக்காங்க. Okay, I'm applying some deformation force which causes my atoms to come in together. Okay, when they come together, their distance decreases, their potential energy increases. It gets skyrocketed. அதனால என்ன ஆகும், they tend to get into the most stable position again, right? So என்ன ஆகும், there is a restoring force. அதாவது பக்கத்தில் வர there is more repulsion இல்லையா. So when there's more repulsion, there is a restoring force between them which pushes them apart. Okay, which is also against the external force which I'm applying, so which pushes them apart and brings them back to this point of least potential energy. I hope this is clear. Okay, paka done. இப்போ this is a rigid body, deformation force சொல்லியாச்சு, and there is something called as elasticity. Okay, elasticity. Rigid body is when I apply force and when there is no deformation, a body is said to be rigid. Okay, fine. In the term சொல்லியாச்சு. So I discovered இது rigid body, and then it's elastic body. Okay, which has elasticity. Elastic you usually call rubber bands. Okay, the thing is, when deformed, okay, when their shape is changed, they have the tendency to come back to their original shape. அதான் வந்து elasticity சொல்லுவாங்க. Elastic stuffs have this elastic property. Okay, fine. நான் சொல்லேன் இல்லையா, restoring force. Okay, the restoring force is based on the elastic property of any substance, and the restoring force, they're based on the same principle. Okay, when you deform something, the position changes, the position of the atoms, relative atoms changes, and their potential energy rises no matter what. So if you increase the distance, potential energy goes up. If you decrease the distance, potential energy goes up. In the mari, so in any possible way, okay, whatever you do, the potential energy is gonna change for sure. Okay, although it not in a negative fashion, but it'll positively increase. அதனால there is always a force that either pulls them apart to the least potential state or pushes them apart to the least potential state. That is your restoring force. Okay, now my elastic property of any substance is based on this restoring force. Okay, whenever I expand, it comes back together. Whenever I push it, compress it close, it comes back together. Okay, simple. This concept இது நான் ஏன் இவ்வளோ எம்ஃபசைஸ் பண்ணுறேன்னா பிகாஸ் இட்ஸ் இம்பார்ட்டன்ட். ஐ டோன்ட் திங்க் இதுக்கு மேலே எவ்ரிவன் வுட் ஹவ் அண்டர்ஸ்டுட். ஓகே, ஜஸ்ட் 1 minute கைஸ், நான் டெம்பரேச்சர் கொஞ்சம் அட்ஜஸ்ட் பண்ணிக்கிறேன். ஸோ ஓகே, பக்கா. டன் 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 டன். ஓகே, இதுக்கப்புறம் வாட் எவர் வி ஆர் கோயிங் டு ஸ்டடி அது பேஸ் பண்ணி கொஷின்ஸ் வில் பி ஆஸ்க்ட். ஓகே, இன் ஆர் எக்ஸாமினேஷன். ஸோ there are few concepts, very few தான் இந்த சாப்டரில். there is something called as stress. See, whenever I move an object இல்லையா, okay, whenever I அதோட ஷேப்பை சேஞ்ச் பண்ணும்போது there will be restoring force which I just now discussed. okay, அந்த restoring force, okay, per unit area எவ்வளோ இருக்கும் அதான் வந்து நம்ம ஸ்ட்ரெஸ். ஓகே, ஸோ it is denoted by force per unit area is nothing but my F by A Newton per meter square, the units. Okay, fine, நீட் எழுதிக்கலாம். Now we know how much force I'm applying externally, and the force will be equal to the restoring force inside, right? Correct? So this restoring force க்கு பதிலா I can write it as deformation force. எழுதலாமா? புரிஞ்சா இது? deformation force எழுதலாமா? okay, fine. okay, clear. okay, fine. Now one more point. This stress is a tensor quantity. What do you mean by tensor quantity? A tensor quantity is the one where you don't have where you have magnitude as usual. All quantities you have magnitude, scalar vector. Okay, and then you have multiple directions and a plane of action. Okay, when you take pressure, okay, this is just literally pressure, yeah, you have a plane, adukku perpendicular you have so many ways the force is getting acted. Correct? So this is an example of your tensor force. Just know it. Okay, the இதுக்கு மேல வரணும்ல. yeah, okay, done, paka. Next, This stress can be normal stress, longitudinal stress, correct? It can be normal stress இருக்கலாம். Okay, where the stress or direction வந்து normal act ஆகும் on the object. Okay, or it can be longitudinal. So longitudinal one example I'll give you. Okay, take you have this இது பேஸ் பண்ணி they won't be any numerical, this is just for an understanding. Okay, you have an object இந்த மாதிரி, you're applying deformation force இந்த மாதிரி, or எப்படி, let's take one case at a time. So when you're compressing it together, okay, இந்த மாதிரி force இருக்குமா, against restoring force acts opposite to the deformation force, right? Fine, pakka, easy. So either இந்த மாதிரி ஒரு force இருக்கும், this is longitudinal again, or you'll have the other way. Okay, the two cases are possible. Fine. இந்த கண்டிஷன்ல longitudinal stressல வந்து the clear longitudinal stressல the length changes. Okay, the length changes. Fine. Okay, now when you consider volume change வச்சுக்கோங்க, volume change. இப்போ this is my fluid வச்சுக்கோ, I'm applying some force external over this area which causes a volume change. Okay, it's all இதுவும் வந்து ஒரு ஏரியா மேலே தான் ஆக்ட் ஆகுது, கரெக்டா? Okay, clear? So இந்த ஆக்டரை there is change in volume. So this is called as volume stress or bulk stress. Okay, done, super easy, pakka, fine. Here it's nothing but pressure, force per area, but this force per area is not acting all over the body. Inga is not acting, rather in the ஒரு area, in the ஒரு cross section மட்டும் தான். ஆனா இங்க it acts on the entire body, so this is called as your pressure. Okay, no doubts. Chat. Okay, thumbs up. இந்த clear-na thumbs up போடுங்க chat, in the live chat, because if you respond now only I can proceed, to be honest. Okay, no thumbs up. Fine, but I'll still proceed. Okay. Okay. Hmm. There is something called as shearing stress. Okay. Okay, thumbs up voting up finally. Okay. Okay, there is something called as shearing stress. Now this concept is a little interesting. The base பண்ணி ஒரு ட்ரிக்கான கொஸ்டின் I'll give you. Okay, now shearing stress is nothing but same force per unit area only. Now this force is acting tangentially. It's acting, நீ இப்படி பிடிச்சி இழுக்கிற tangential. This is இதுக்கு you're either pushing it இந்த மாதிரி where this is மேலே இப்படி and the கீழே இப்படி இப்படி புஷ் பண்ணுறேன். Okay, ஸோ இந்த மாதிரி புஷ் பண்ணும்போது you have force. Okay, the deformation கொஞ்சம் இந்த மாதிரி வரும் கரெக்டாக. Something like this. Okay, similar. Fine. This is your shearing stress. Okay, now one important question, super important. Load ஆமாட்டிது. Okay, clear. Now I'll give you the question மட்டும். One second. Okay, same shearing stress force இப்படி ப்ளே பண்ணுறேன். Okay, correcta? This is shearing stress. Fine. Okay, no one's replying, bro. I'm not waiting. Okay, shearing stress either. Okay, now say I'm applying in the mari. Okay, I'm going to find the stress. I'm applying force tangentially f இப்படி and I'm about to find the stress in the area. Okay, I told you stress is not pressure. Okay, it's pressure when it changes the volume. Okay, in the case la it's not, see, pressure is suppose something that's uniform on an entire body. So என் மேலே பார்த்தீங்கன்னா atmospheric pressure acts the same way throughout my body. Okay, patch பச்சப்படாது. So but இங்கே பார்த்தீங்கன்னா here area பொறுத்து this thing changes. Okay, so this is not pressure, rather is stress. Okay, now I'm supposed to find the stress. Okay, the stress in this area, in the area la எவ்வளோ stress act ஆகுதுன்னு நம்ம கண்டுபிடிக்கணும். Okay, say this is இதோட area cross section A. Okay, it makes an angle of theta இப்படி. Okay, so since f இப்படி act ஆகுது, I could write it here இந்த மாதிரி. Okay, which will be like, which is this. Okay, but I want the stuff which acts perpendicularly. Okay, so this will be my perpendicular force. This is f. This will be theta. Okay, because yeah, so, and this will be my f cos theta. Correct? Okay, now f cos theta. Okay, now in the area என்னன்னு கண்டுபிடிக்கணும். So this is A, The area is A. This will be A by cos theta va. Correct. So what is stress, which is nothing but force by area va. So my force is F cos theta, which is acting perpendicularly, and my area is A by cos theta. So my stress is equal to F cos square theta by A. இந்த கொஸ்டின் ஏதாவது டவுட் இருக்கா? சாட் பாக்ஸில் தம்ஸ் அப் போடுங்க இஃப் யூ ஆர். Okay, thumbs up. This is my tensile stress. Okay, fine. Okay, now I found out in the either clear. Now I am applying shearing force on this object இந்த மாதிரி மேலே மேலே இப்படி இது கீழே இப்படி இந்த மாதிரி. Now let's consider the same thing for that area. So இப்போ அந்த ஏரியாக்கு நான் கன்சிடர் பண்ணோன்னா my shearing stress for this small area will be, for in the area will be, let me denote it with green. Okay, this will be my shearing force. Pakka tangential. Okay, this is my shearing force. Okay, the shearing force is nothing but F sin theta va, because this is the F இது F cos theta. F cos theta perpendicular F sin theta. Okay, one minute. தப்பா இது வந்துட்டா. The lines is supposed to be like this. Okay, same. Okay, so my shearing stress over that area will be equal to F sin theta by A by cos theta, which is equal to F sin theta cos theta by A, which is nothing but F sin 2 theta by A. Okay, இந்த டாபிக் வச்சு இதை விட கஷ்டமா questions in your NEET examination they won't ask. Okay, fine, clear. Fine. Okay, then just one. Okay, thumbs up production. Sorry, it's in a bug. Phone was not working. I can't see live chat. Okay, fine. Okay. Now the next topic is also very important. In the first topic is which is stress. In the next topic, strain. இதை வந்து இந்த entire thing drive பண்ணுது. Okay, so you have strain. Entire chapter is driven by these two topics only. Okay, strain is nothing but, see, when you apply deformation force, okay, உனக்கு தெரிய deformation force apply பண்ணிட்டு when you apply deformation force, there is some deformation. Okay, அந்த deformation இல்லை, there is change in length இருக்கலாம், in area இருக்கலாம், change in volume இருக்கலாம். Okay, shear deformation கூட இருக்கலாம். Okay, shear வந்து tangential. Fine. All this causes which where there is some deformation, and the deformation or the level or the ratio of change. Okay, yeah, ratio of change, deformation or a ratio with your original values gives your strain. Okay, simple. So strain is nothing but ratio of deformation by original. Okay, done. Okay, paka. Now let me tell you about strain oda வேற types மாதிரி வச்சுக்கோங்க. There is a longitudinal strain, and you have volume strain obviously, and then you have shear strain or shearing strain. Okay, இது வரைக்கும் numericals வரல, but still these are all basic stuffs. Okay, longitudinal strain is nothing but your change in length divided by initial length. This is your longitudinal. Aerial is volume change is nothing but your change in volume divided by initial volume. The volume strain. Okay, and then you have something called a shearing strain. The shearing strain is little different. Okay, இது nothing but your given as the see, when what is shearing strain now, you have something and then you're applying tangential force. Okay, so when you apply tangential force, the perpendicular plane in the pakam, it will move through some angle. Okay, the shearing strain is nothing but the change in angle of the perpendicular plane. I don't know why I closed my eyes, but yeah, I was trying to imagine the perpendicular angle. Okay, so yeah, so when இந்த மாதிரி deformation ஆகும்போது, okay, இந்த மாதிரி deformation ஆகும் இல்லையா, it makes an angle theta and it makes an angle theta here. It makes an angle theta, it makes an angle theta. ரெண்டு theta form பண்ணுது. Now this theta is nothing but my this is my area, this is my it's length change. Okay, this is my area and this is my change in length, or in the length, in the side or length, let it be a, not area, sorry, where is the pen? Side length. Okay, so theta is nothing but sine theta will be so very equal to, no, in the case it's nothing but opposite by adjacent, opposite by hypotenuse, but this won't be same. Okay, sorry, I'll color it in different. Okay, because length will also change in the change agum, and this will also change. So this, take this as L. Okay, take this as change in length, take this as L, and take that as change in length. So my tan of theta will be equal to change in length divided by and then the length. So where theta is approximately equal to tan theta in the case lab, because it's so small. So my theta is nothing but my shear strain. Okay, paka. So this is stress and strain for you. Okay, okay. Let's solve few questions. There's a beautiful concept. I'll teach you. Let's solve few questions. We'll take a small break, and there are beautiful concepts yet to come. Okay. Okay. Let's say a copper wire of length 1 meter. Okay. I'm having a copper wire of length 1 meter. In the 1 meter length இருக்கிற copper wire am I extending by 1 centimeter. I'm extending by 1 centimeter. The question is so simple. Okay, what we're supposed to find now, the what we're discussing, strain. Strain கண்டுபிடிக்கணும். Strain is nothing but change in length by initial length. Okay, ratio of change in length by initial length, ratio of change in length and initial length, or ratio of, or change in length by initial length. Okay, so 1 centimeter, which can be written as 1 into 10 power minus 2 meters divided by 1 meter, is my change in length by initial length. So this can be written as 10 power minus 2. Okay, this is my strain. Now when you notice here, the strain, it has no units. Okay, it's a dimensionless quantity. Yeah. One more question. I have so many questions for you guys. Okay. Now this is a simple way of simple question that they ask. Oh, okay. One more question is where they tell you, say a wire, அதோட length is changed by this much percentage. Say 0.5 percentage is the change in length. When that's the case, okay, 0.5% change in length, can be written as change in length by initial length equals to 0.5% by 100. So change in length by initial length is nothing but 5 into 10 power minus 3. So this is my strain. Okay, basic questions. Okay, this is how basic stuff can be. இதை விட பேசிக்காக இருக்காது. Now there is a concept called elastic limit. elastic limit. Elastic limit. Okay. Elastic limit is the maximum stress that some object can actually experience, okay, before breaking apart. Fine. Before it can either no longer regain its previous original shape, because when you say I am pulling a rubber band, when I pull it, it comes back together, okay. But when I pull it to like a large extent, it eventually breaks, okay. That is for rubber band, where it just breaks apart, okay. We have other stuffs as well. um, Say a rod, okay, iron rod. When I'm extending, to some extent it will increase and it will go back to its original shape, okay. But since they're super ductile, that's very rare. But still, yeah. Okay, say a rubber band as so an eraser. When you expand it, it comes to some extent, okay. Okay, and then it goes back. It comes to some extent, it goes back, okay. That's when the deformation force and restoring force all are acting fine, done. But when you extend it even farther, okay, after some point, the restoring force won't pull it back and come become the original one again, okay. அந்த டைம்ல வந்து, okay, the potential energy which is stored inside, okay, it releases as heat, okay. So yeah, so again the system gets into a more stable state, and there won't be any restoration of its previous shape. So that is your elastic limit. I hope everyone understood this. Okay. Now this concept was a simple thing. Okay. And it's not working. Okay. Now we have Hooke's law. Okay. The Hooke's law முடிச்சிட்டு we have Young's modulus, and then we have a few questions. அதுக்கப்புறம் we'll finish this chapter. Okay. Hooke's law. தமிழ் டீச் பண்ண ப்ரோ, இது தமிழ் சேனல் தானே? ஓகே ப்ரோ, தமிழ்லேயே டீச் பண்ணுறேன். ஓகே. ஹூக்ஸ் லா. நான் வந்து தமிழ் அண்ட் இங்கிலீஷ் ரெண்டுலேயும் சொல்லித்தரேன். பட் யா, ஓகே. Okay. It's found that, okay, Hooke's law states that stress and strain, okay, ரெண்டுமே வந்து proportional சொல்கிறாங்க to some extent. Up to some extent, the more amount of stress I give to an object, okay, எவ்வளோக்கு எவ்வளோ ஸ்ட்ரெஸ் தரனோ அந்த அதே அளவான ஸ்ட்ரெஸ்ஸுக்கு there will be strain, there will be change in length, okay, and they are proportional to each other. அதாவது my f by a is proportional to L by L. எப்போ வரைக்கும்? To some extent. Okay. When people plot a stress strain graph of few stuffs, okay, say this as my stress and இது என்னோட strain. Okay, so when you see initially ஒரு சின்ன level of stress apply இருக்கு, there will be strain which is proportional. Proportional வந்து line will be straight. Okay வா, fine. Okay, அப்புறம் இந்த பாயிண்ட் வரைக்கும் my thing is proportional. Okay, அதுக்கப்புறம் அது ப்ரொபோஷனலாக இருக்காது. ஓகே, ஏன்னா அதுக்கப்புறம் ஓகே, இது 1 2. ஓகே, ஃபைன். இப்போ வந்து let's take இந்த பாயிண்ட்லாம். So this is my point number 1, this is my point number 2. Okay, this is my point number 3, number 4, and point number 5. Okay, fine. இப்போ நீங்கள் பார்த்தீங்கன்னா தேர் ஃபஸ்ட்டு என்னோட பொட்டென்ஷியல் ஸ்ட்ரெஸ் அண்ட் ஸ்ட்ரெயின் வந்து தே ஆர் ப்ரொபோஷ்னல். ஓகே, பக்கா ப்ரொபோஷ்னல், அதாவது டைரக்ட்லி தே ஆர் ப்ரொபோஷ்னல் டு ஈச் அதர். ஃபைன், திஸ் இஸ் நைஸ். இந்த ரீஜனில் இந்த ரீஜன் இருக்கு இல்லையா, this is what my Hooke's law states. To some extent இது ப்ரொபோஷனல். அதுக்கப்புறம் when you expand some say a wire, okay, wire expand பண்ணுறேன், to some extent the stress and strain are proportional. okay, எவ்வளோக்கு எவ்வளோ ஸ்ட்ரெஸ் அப்ளை பண்ணுறியோ அவ்வளோக்கு எவ்வளோ ஸ்ட்ரெயின் இருக்கும். அதுக்கப்புறம் நீ கொஞ்சம் ஸ்ட்ரெஸ் அப்ளை பண்ணுறக்கே there will be more change. that is in the point, in the region. okay, இதில் வந்து you have 2 points. ஓகேவா, ஃபஸ்ட்டு ஒன்று this is not A point, this is not B point, and this is C point. Okay, when I stop it at B point, okay va, when I stop applying stress at B point, என்னோட ஆப்ஜெக்ட் வந்து திரும்ப அதோட ஒரிஜினல் பொசிஷனுக்கு போயிடும். ஃபைன், ஒரிஜினல் பொசிஷனுக்கு போயிடும். ஓகே, பட் when I do the same thing, when I increase the stress till point Cல இருக்கிற ஸ்ட்ரெஸ் வரைக்கும் இஃப் ஐ அப்ளை ஸ்ட்ரெயின் வரைக்கும் இஃப் ஐ அப்ளை ஃபோர்ஸ், இந்த ஸ்ட்ரெயின் இருக்கு இல்லையா, எனக்கு இவ்வளோ ஸ்ட்ரெயின் வந்ததுக்கப்புறம் நான் ஸ்ட்ரெஸ் அது வரைக்கும் நான் ஸ்ட்ரெஸ் அப்ளை பண்ணியிருந்தேன்னா அது வரைக்கும் இஃப் ஐ அப்ளை ஃபோர்ஸ், அதுக்கப்புறம் தி ஆப்ஜெக்ட் won't return to its original shape. ஓகே, ஸோ அது அப்படியே இருக்கும். ஸோ திஸ் இஸ் வேர் இட் கெட்ஸ் permanently set. My B point is where I can remove the amount of load on it and it will go back to its original point. So it's called as yield point. Okay. Okay. அப்புறம் இந்த D பாயிண்ட்டும் என்னது, D பாயிண்ட்னா என்ன கேட்குறீங்க அப்படின்னு. D point and E point, this is D point and this is E point. இது என்னதுன்னு நீங்கள் கேட்டிங்கன்னா, see my D point is where, okay, D point வரைக்கும் if I increase the stress there will be strain. Okay, okay. So my point D வரைக்கும் increasing stress, அதுக்கப்புறம் there is strain, okay, where which increases with the increase in my stress, okay. After point D நான் வந்து ஸ்ட்ரெஸ் கொடுக்குறது நிறுத்தி அப்படியே கொஞ்சம் கொஞ்சமாக குறைச்சிட்டு வரேன், ஓகேவா. ஐம் அப்ளைங் சே ஃபஸ்ட் இனிஷியலி 10 நியூட்டன் பர் மீட்டர் ஸ்கொயர்னு வச்சுக்கோ. நான் டி பாயிண்ட்க்கு அப்புறம் நான் 8 நியூட்டன் பர் மீட்டர் ஸ்கொயர் அப்ளை பண்ணாலும் there will be strain, there will be deformation. So after D, even if I, so till here if I take 10 Newton per meter square, okay, after D if I apply say 8 Newton per meter square, அப்போவும் there is strain. பக்கா, அப்போவும் there is strain, okay. Okay, now after E, and it reaches to a point where if I keep on reducing the force as well, when I keep on reducing the force, there is still strain, and ஒரு கட்டத்துக்கு அப்புறம் it will break, okay. And that point where there is complete deformation is point E, okay. Here is இங்க தான் வந்து fracture ஆகும், the stuff just literally breaks apart, okay. Okay, breaking stress, yeah. Okay, fine. Now there are இதை வந்து you'll use a lot in understanding the substances பற்றி, ஓகேவா. if you have somethingனா அந்த மெட்டீரியலோட ப்ராப்பர்ட்டிஸ் அண்டர்ஸ்டாண்ட். ஸோ ஃபார் கன்ஸ்ட்ரக்ஷனுக்கு தேர் யூசிங் சம் மெட்டீரியல், ஓகே, சே தேர் யூசிங் சம் மெட்டீரியல் ஃபார் சம் அதர் பர்பஸஸ். இந்த மெட்டீரியலோட டக்டிலிட்டி, ஹார்ட்னஸ், எவ்வளோ பிரிட்டிலாக இருக்குது, அதோட ஜென்ரலைஸ்ட் ப்ராப்பர்ட்டிஸை அப்புறம் அண்டர்ஸ்டாண்ட் பண்ணுறதுக்கு we are using this stress strain graph, okay, fine. Now the questions will arise இந்த மாதிரி, okay, questions will be asked இந்த மாதிரி. See, this is my stress strain graph. இந்த கான்செப்ட் நீங்கள் இப்போ அண்டர்ஸ்டாண்ட் பண்ணிட்டீங்கன்னா you won't forget for life, okay. Okay, this is stress, okay. This is my strain, paka, okay. So when I apply, let's take two materials, okay. ரெண்டு மெட்டீரியலோட ஸ்ட்ரெஸ் ஸ்ட்ரெயின் கிராஃபை நான் வந்து ஒரு வேறு லைனை டிபிக் பண்ணுறேன், ஓகே. வெறும் இது வந்து இட்ஸ் நாட் என்டையர்லி ரைட், ஓகே, பட் ஸ்டில். Okay, this is my substance A, this is my substance B. Now the question arises, இதில் எந்த சப்ஸ்டன்ஸ் வந்து, why did you use HCV bro? Did you use for HCV? I use it for my preparation, I sometimes use it for my classes as well, okay, yeah. So this இது இருக்கு இல்லையா, now see, இந்த A இருக்கு இல்லையா, this A and B ரெண்டு சப்ஸ்டன்சஸ் இருக்குது, ரெண்டோட ஸ்ட்ரெஸ் ஸ்ட்ரெயின் கிராஃப் இஸ் given. Now I want to know which one is stiffer and which one is stronger, okay. In the end point represents my E point, okay, the fracture point, correcta. In the point represent பண்ணுது, Okay, now tell me in the chat box which one is stiffer and which one is stronger. Come on guys, சீக்கிரமா. I practiced a lot of JEE mains previous year questions, like a lot of them. Okay, now question கேட்டதுக்கு tell me the answer guys, come on. Okay, so நானே சொல்றேன். Fine. See, when you call an object stiff, okay, see wood இருக்கு இல்லையா, wood is super stiff. Okay, நீ stress எவ்வளோ அப்ளை பண்றியோ அப்ளை பண்ண there won't be much change in its length. Fine. So when there is no much change in its length for the same amount of stress apply, see இந்த stress பார்த்துக்கோங்க, இந்த stress level பார்த்துக்கோங்க. Let's take ஒரு line, take blue. இந்த level of stressக்கு force applied இருக்கு. The blue had இங்க இந்த this is my blue ஓட plot and this is my red ஓட plot. Blue had this much strain, well B had this much strain. Okay, B had more strain than A. Okay, B had more strain than A. அப்போனா என்னன்னா, for the same amount of stress A had lesser deformation, yes, lesser strain. அப்போனா my A is stiff. Okay, but my B, it stood for a long time, it stood for more strain. So அது வந்து நிறைய stress வந்து it was under so much stress before it broke out. Okay, broke apart. Line. Okay, it was under so much stress before it broke out. Okay, இது வந்து இவ்வளோ ஸ்ட்ரெஸ்லேயே முடிஞ்சிருச்சு. This is my over stress, this is my no stress. Okay, stress difference. So it had my red color wire was under more stress, my B wire was under more stress than A. So B is more stronger and A is more stiffer. Okay, fine. So yeah, this topic is over. Hooke's law application. No, fine. இப்போ Hooke's law, it stated that okay, my stress is proportional to strain. Yeah, okay, to some extent. அப்போனா I could write it as stress by strain equals to constant. Okay, this constant is known as modulus. Okay, you have so many modulus, yeah, Young's modulus, bulk modulus. Okay, அதெல்லாம் we'll see. Okay, now there is an NCRT graph for you. NCRT graph. NCRT graph question which can be asked in your NEET 2026 examination. It's an NCRT graph. இது வந்து just factual data you must know. Okay, questions கேட்டா you should be able to answer. Stress, strain. Okay, when stress strain graph for an elastomer for rubber band, usually rubber band தான் நினைக்கிறேன் in NCRT. Okay, when it's taken அதோட graph for something like this. Okay, where stress is in 10 power 6 Newton per meter square. This is your graph. Okay, just know this is important. This is your NCRT graph. Okay, done. Pakka. So yeah, I have a question for you guys. This is a very interesting question. In the question முடிச்சிட்டு we'll take a break for 10 minutes. அதுக்கப்புறம் we'll discuss the other topics. இதுக்கு மேல topics are easy. Simple topics. Okay. Now if you see, the question is, say I'm having a block of mass 1 kg. 1 kg mass இருக்கு, and then it's on a copper wire of cross sectional area 1 millimeter square. The copper cross sectional area. Okay, the copper wire length is 20 centimeter. So this 20 centimeter length, 1 millimeter square cross sectional area, 1 kg mass. இந்த copper wire breaking stress இருக்கியா, it is 5 into 10 power 5 Newton per meter square. Okay, done, fine. Okay, so 5 into 10 power minus 5. Okay, the question is, now say this entire system is rotating in a horizontal motion. Okay, so I'll have some centrifugal force, and the centrifugal force should be equal to the stress. Okay, and then the stress, and that will be attained after some amount of rotation. எவ்வளோ rotation அப்புறம் will my copper wire reach to the point where it'll have this, where it'll have the stress equal to its breaking stress. Okay, fine. So the force per area is nothing but my five into உங்களுக்கு question புரியும். Okay, அப்போ solve பண்ண 10 power 5. So my force is equal to, area is nothing but 1 millimeter square. 1 millimeter square is nothing but 1 millimeter is 10 power minus 2 minus 3 square is minus 6. So 5 into 10 power Okay, this is 8, 10 power 8 into 10 power minus 6 is equal to 500 newtons of force. So உனக்கு force வந்து 500 newtons of force இருக்கணும், which will be equal to my mr omega square. Correct? Okay, my mr omega square is nothing but 500 equals to 1 into 20 into 10 power minus 2, where r is the radius of this circle it makes, and the length is nothing but 20 centimeter, into omega square is what I'm supposed to find. Omega square is, okay, omega square. Okay, so இது வந்து எப்படி எழுதலாம்? So 2500 under root is equal to my omega. Omega is equal to 50. Pakka? Fine. Omega 50. If omega is nothing but 2 pi by total time taken. 2 pi is the one single rotation. 2 pi into number of rotations by total time taken is equal to 50. Okay, fine. Repeat it. Or this omega can be written as in RPM format. RPM is nothing but 2 pi divided by where time is in t. So yeah, 60. When you solve this, your n will be equal to 50 into 60, which is 3000 divided by 2 pi. 3000 divided by approximately 6 na be equal to 500 ish, or some 470 to 500. So number of n is equal to 400, 470 to 500 ish. அத்தனை rotations per minute இருந்துச்சுன்னா it will get 500 newtons of force, which 500 newtons of force it would have reached its breaking stress. Clear? Yeah, 50 correct. Thank you so much, Safura. Bro, just say the coaching institute you went to. Don't ignore questions that take 1 to 2 seconds to answer. Coaching institute, I don't think I'm supposed to answer that. Okay, 470, 4700. No, not possible. I don't have to answer that. Whatever your name is. Okay, done. Paka. There is a way to ask questions. Okay, அந்த மாதிரி கேட்கறதுக்கு நான் பதில் சொல்லணும் அவசியம் இல்லை. Fine. Hooke's law. This one, this one, this one. So yeah, இதுக்கப்புறம் Young's modulus படி அடுத்த, its time is 8:15. Let's start the class at 8:35. Okay, a 20-minute break as usual. Class resumes at 8:35 p.m. Okay, boy, if you can have your dinner. Okay, I'll be back கொஞ்ச நேரத்துல. Yeah. Hello, 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 everyone. We are back. We are so back. Am I audible? Yeah. Yes, I am audible. Okay. Hmm. Audible. Thank you. Yup. Safura. Okay. Hmm. Thank you. Hmm. All right. Let's get into the next topic, okay? Which is super simple. Camera focus is there. Sing. Perfect focus. Hmm. Okay. Last question for it was around. Okay. Yeah, I was so lazy to calculate. Thank you. You have to use 3.14 for அதுக்கு I was like சும்மாவே எடுத்துடலான்ட்டு. Okay, fine. Never mind. Don't solve the way I did, okay? It's so wrong. Mm. Okay, now, in the next topic, Young's modulus. We discuss about various moduluses. We will discuss, okay, further up. இப்போ discuss I told you what are moduluses. Nothing but in Hooke's law you had stress proportional to strain. Okay. இந்த கேஸில் when you have that அந்த மாதிரி இருக்கும்போது nothing when that அந்த அப்போ your stress by strain will be equal to some constant, okay, and that constant is called as modulus. Okay, Young's modulus is when you have tensile stress by longitudinal strain. Okay, so when you equate tensile stress and longitudinal strain, it's your Young's modulus. Okay, super simple. Okay, so tensile stress is nothing but force per area. Longitudinal strain is nothing but del L by L. This del L or change in length can also be represented by a variable E. Okay, இது equal to யார் Young's modulus y. Young's modulus வந்து y ஆட represent பண்ணுவோம். Okay, so it can be written as F into L divided by A into del L equals to y. This is my formula. Paka, clear? Okay, nice. இப்போ so yeah, Now if I have to include, this is my Young's modulus, okay? If I want to include, okay, சின்ன mistake it's okay, but it's not mean. If I want to include my volume in that, so it will be FL by A del L. I can multiply with A divide and with A by A, which will be equal to my Y. So it will become FV by A square del L equals to Y. Okay. Either one form or to include volume, you can modify the same equation by multiplying with L by L. Here A by A kuda, here L by L kuda. You'll get F L square divided by V del L equals to Y. Pakka, clear. This is how you include your volume with your Young's modulus equation. Fine. Okay. Why do I have to include volume? கேட்கலாம் ஏன் வந்து இப்போ நான் சும்மா நல்லா தானே இருக்கு இந்த ஈக்குவேஷன் ஏன் வந்து நான் வால்யூம் include பண்ணணும் if you ask me, it's simple. Okay. See, when you take an object, okay, அந்த ஆப்ஜெக்ட் யூஆர் சே ஸ்ட்ரெஸ் இப்படி ஆக்ட் ஆகுது. Fine. It feels so cold. Okay. When you're applying force in the மாதிரி, the object's length is changing, obviously. And the change in length and the object length or a relation I have to find. Okay, but I don't have its area because when you pull it, okay, other area keeps changing. Cross sectional area first thicker இருக்கிறது, okay, thicker it'll get on thinning. Okay, area will keep on reducing when the length is increased. Okay, everyone knows that because volume is constant. So when you want the volume to be constant in this, okay, and equate the change in length வால்யூம் கான்ஸ்டன்ட்டாக எடுத்துகிட்டு சேஞ்ச் இன் லென்த்தையும் இனிஷியல் லென்த்தையும் ஈக்குவேட் பண்ணணுன்னா யூ கேன் யூஸ் திஸ் ஃபார்முலா. வால்யூம் கான்ஸ்டன்ட்டாக எடுத்துகிட்டு சேஞ்ச் இன் லென்த்தையும் ஏரியாவையும் இஃப் யூ வாண்ட் டு ரிலேட்னா யூ கேன் யூஸ் திஸ் ஃபார்முலா. ஓகே, ஐ கிவ் யூ ஸோ சே இப்போ வந்து இந்த ஃபார்முலாவில் ஐ குட் டேக் and my relation is del L is proportional to del L is nothing but E. Okay, E is proportional to my L square. Now I can write as for various objects E1 by E2 equals to L square by L1 square by L2 square. Okay, further if you want to include say density, say if you want density, mass by volume is density. Okay, if you want to include density you can use it here. Okay, you add, I mean you multiply FV by A square del L A square del L இது கூட you multiply with M by M கூட multiply பண்ணும்போது you will get FV by M A square del L. So V by M is nothing but 1 by D, so F by D A square E or del L. Read both. Hi. My throat hurts a little. I had to drink coffee. Don't know, some infection probably. Done, guys. Now, a concept. Okay. When you have a rod, say a rod இருக்கு. Okay. The rod, it's so heavy because okay, it's so heavy that அதோட length started increasing because of its own weight. அதோட own weight வந்து அதை drag பண்ணி அதோட length increase பண்ணுது, which is weird, which is okay. Okay. Say a rod இருக்கு. It has a mass of m. It has a length of l. Okay. It increased by a small dx length. Okay. dx length increase ஆயிருக்கு. And இப்போ okay. See. Okay, I'm not dropping my pen down again. It causes so much noise. Okay, இதை வச்சு பார்த்துக்கலாம். Okay. This pen, say this is my rod. Okay. Say if just a simple logic. Okay. In the pen order length, if it increases in the point, okay, in the point la, if idoda length increase aachina, then the length increase in this point is due to the mass below it. Everyone knows this. The mass below it only causes it to increase its length. Simple. So I can say it's safe to say that this dx length change was because of the mass below it. Let's say this dx, I mean the length of the rod below it is x. Okay, fine. Okay. Okay. Fine. Now let's write our equation. F by a into L by del L equals to y. This is our Young's equation, modulus order equation. இப்போ இதில் வந்து I am using f க்கு பதிலாக is nothing but mg, and mg is because of this mass only, this mass, and not the entire mass. So I am considering linear density. Okay, so m divided by L is my linear density into x is my in the portion order mass. Okay, this is my mass into gravity is my force into correct mass into gravity. Okay, divided by a del L. A is the area of cross section into del L is nothing but E, which is equal to my Young's modulus y. Okay. Now இங்கே வந்து I think no one's replying. Okay, but still, so I'll proceed. There are these awkward pauses in my lecture. Okay, suddenly I'll be silent. அப்போ நான் வந்து I'm looking for a chat response தான், but no one's replying. So yeah, I'll proceed. Never mind. இங்கே வந்து நான் ஒரு டேர்ம் மிஸ் பண்ணியிருக்கேன் தெரியுதா? What is this term? This is my L. Okay, fine. What is my L? So I'm considering this small portion dx to be the length of the object. Okay, this length of this dx length வந்து நான் x into m by l mass வச்சு நான் புல் பண்ணுறேன். It will cause a dE change in its length. அந்த dE change நான் கண்டுபிடிக்கிறேன். Okay, fine. சின்ன லென்த்தோட சின்ன டீவியேஷனை I'm integrating it to find the entire length of the rod. Fine. So this is my dx will be my chinna changes the dE. Okay. Mass can be written as volume into density. Volume is nothing but area into length into density divided by length again divided by area again into y into x into g into dx equals to my dE. How this came? Now area cancel, length cancel. Okay, so I have density x dx divided by y. Integrate this. Integrate panna I'll get dg L square divided by y, which is equal to E. So this is my elongation of rod because of its own weight, which is nothing but density into acceleration due to gravity into length square by y. Clear? Okay. Thank you so much, Safura. You're the only one responding. Chat box is so dry, guys. Come on. Yeah, message I'm sharing. Ask your doubts, anything. Yeah. These are concepts that I had to discuss. Okay. Next you have thermal stress. Just a minute. Throat feels so better now. Okay, coffee, caffeine. Fine. I don't know why I said that. Okay, but apparently நான் நிறைய caffeine consume பண்றேன், which is not good. Okay, there is something called as thermal stress. Thermal stress. This is something you'll study in your thermal properties of matter. Okay, fine. But I'll give you the basic idea. See, when you heat an object, it will increase its length. Okay, the length depends on two factors. One is your initial length. So if you had 1 meter of wire and a 10 centimeter wire and you heat them both to the same temperature, okay, finally 1 meter would have increased by a larger length compared to the 10 centimeter length. கரெக்டாக? ஸோ இனிஷியல் லென்த் எவ்வளோக்கு அதிகமாக இருக்கோ அவ்வளோக்கு இன்க்ரீஸ்டு சேஞ்ச் இன் லென்த் இருக்கும். அண்ட் ஆல்சோ எவ்வளோக்கு எவ்வளோ டெம்பரேச்சர் சேஞ்ச் இருக்கோ, ஸோ 10 டிகிரி சேஞ்சை விட 100 டிகிரி சேஞ்சுக்கு தெர் வில் பி மோர் இன்க்ரீஸ் இன் லென்த். ஸோ இந்த ரெண்டு ஃபேக்டர்ஸ் பேஸ் பண்ணி we have an entire chapter, okay, based on this, okay, based on thermal properties of matter. This is mechanical properties of solids. இதில் see, when you have increased temperature, okay, so that there is change in length which is equal to initial length into its linear coefficient into its change in temperature. Okay, this is my change in length. இது எங்கேயோ பார்த்த மாதிரி இருக்குது இது ரெண்டையும் சேர்ந்து. Which are strain. Okay, so del L divided by L equals to alpha delta theta, where theta is my temperature change and alpha is my coefficient of linear expansion. Okay, you would have studied. தெரியலனா we'll discuss in thermal properties, don't worry. Now இது இருக்கு இல்லையா, இது வந்து can be, this is nothing but my F by AY, right? எழுதலாமா? Fine. Which is nothing but force in by area equals to y alpha delta theta. So this is my stress due to thermal expansion. பக்கா clear? புரிஞ்சா எல்லாருக்கும்? Okay. Thank you so much, Safura. Okay. See, like literally the only person that responds in the chat. Okay, never mind. Okay. Now there is something called as bulk modulus. So that was our Young's modulus. Then we have bulk modulus. Okay, இது ரெண்டு பேஸ் பண்ணி தான் questions will be coming. Okay, இதுக்கு மேலே okay, one thumbs up, one. Okay, so sad. Bulk modulus. Okay, fine. Okay, bulk modulus is nothing but change in the bulk. Okay, change in bulk இல்லைனா volume. Okay, so modulus is nothing but our stress by strain. Okay, so in bulk modulus is nothing but our change in volume by initial volume, which is my volume strain. Okay, to that of my force per area. So it will be nothing but F by A into V by del V. This is my bulk modulus. Okay, volume stress is nothing, can be also, you can also be written as F by A. I told you F by A is stress when it acts, when it comes under, when it is called as pressure. Now when for every area if it's constant. Okay, அந்த ஒரு கொஷின் பார்த்தோம் இல்லையா, டென்சர் ஃபோர்ஸ் அப்போ இந்த ஏரியாவுக்கு there was a separate pressure, separate stress. Okay, but if we consider pressure for every unit cross sectional area, the amount of force acting on it will be same. Fine. So for bulk it's so easy to call it as pressure. And also here it's nothing but change in pressure. It's volume stress, அதாவது உன்னோட external pressure change into V by del V. Okay, paka. This is my bulk modulus. Okay, super, thank you. Hmm. Hmm. So I think these are almost all the concepts that's required for NEET. Okay, இதுக்கப்புறம் you have one more topic, then we'll solve questions. Yeah, I didn't write that as well. Okay. Mm. Concept. You have ரெண்டு ஆட்டம். ஓகே, ரெண்டு ஆட்டம் இருக்கு. அதை பக்கத்தில் கொண்டு வர. ஓகே, இட்ஸ் இன் ஈக்குலிபிரியம் ஸ்டேட். ஓகே, அதோட பொட்டென்ஷியல் எனர்ஜி அது வந்து ஒரு லெவலில் இருக்குது. ஃபைன், பக்கா. ஒரு கட்டத்துக்கு அப்புறம் when you push it together there will be repulsive forces because of which potential energy becomes positive, which is also right, பக்கா. You'll get positive. இப்போ when it comes close, okay, say after some time it doesn't change its shape. Okay, அதை வந்து ரிஜிடாக ஃபிக்ஸ்டு ஷேப்புக்கு வந்துடும். Okay, I'll explain it again. See, when you have given it some sufficient amount of stress, okay, say in the point, where is my when it is at C, permanently set point, okay, and the point la still say I'm compressing it and it got permanently set. Okay, compressing it and it got permanently set. So when I'm compressing it, okay, when I'm compressing the thing, the atoms come close together, the potential energy increases. Okay, this potential energy increase is linked with the stress I'm applying, correct? One, and now it was also linked with the change in length, correct? I'm compressing it, so length குறையுது. length குறையிறதையும் நான் அப்ளை பண்ணுற அந்த கம்ப்ரெஷன் ஃபோர்ஸையும் I can relate it with my potential energy இல்லை? Okay, fine. Okay, this concept you have it. This is what we are going to discuss. There is one more thing I have to discuss here. So when you do that, okay, say I'm doing the same process. I'm compressing it and then expanding it, compressing it and expanding it. You can observe that the object gets heated up. Heat develop agum. Heat is developed because the potential energy which gets increased in the time lab, it gets converted into heat energy. Fine, because it gets converted into heat energy, it becomes the potential energy of the two particle system gets lower, so that it becomes set. Fine. Okay, now this concept is separate. Now first is another, it's we are going to derive an equation. After this we'll be solving questions. Fine. Okay. We all know work done is equal to force into displacement. Okay, so I'm applying force. Okay, I'm applying force and the displacement I do on the object is the change in length. Say I do a small change in d change d change in length. Okay, so my dw is equal to f into d. My f can be written as f by a into l by e equals to y. F can be written as y into a into e by l. Okay, so f by l I'm writing it here. Okay, so y into a into e divided by l into d is equal to dw. Fine. So on I'm integrating both sides. So work done, dw becomes w is equal to y into a into e del is nothing but e square by 2l. Correct. Reply broski, guys, 2 days 80 plus password I didn't read for both because my aunt got cancer. I was worried about her. Please tell. Okay. Can you explain your situation or problem issue a little bit more uh, in detail? Because it seems like you studied for boards ரெண்டு மட்டும்தான் ரெண்டு படிச்சுட்டு and you are expecting 80 plus possible or your boards are upcoming or have you completed your boards already? Just let me know if your boards are yet to come. I got you. முடிஞ்சிருந்துச்சுனா there's nothing we can do. Okay, fine. Okay, super. This is work done out of a form of equation. Okay, nice. The work done can also be written as half into F into E. Fine. Okay. Okay. Fine. Now I'm supposed to find did he explain this? Oh no, or explain பண்ணல. Okay. Did he? Okay. Now the strain ala energy வருது. So it's called as strain energy per unit volume கண்டுபிடிக்கணும் because that's how it is. Okay, அந்த மாதிரி தான் calculate, அந்த மாதிரி தான் questions are raised. So half into F into E divided by volume is A into L is nothing but half into stress into strain, or it can also be written as half into stress square by y, or half into strain square into y. அவ்வளோதான். இதுக்கு மேலே there are no more questions that will be arised from this topic. இதெல்லாம் தான் வந்து உங்களோட questions, I mean formulas. Okay, fine. இப்போ there are few questions with Young's modulus I'll discuss, and then அதுக்கப்புறம் we'll finish off this chapter once and for all. Okay. Let's solve little difficult questions. Okay, so we'll have proper understanding. Okay. ஏன்னா சிம்பிளாக இது நீ ஸ்ட்ரெஸ் கண்டுபிடிச்சி you can use this formula to find stress energy. You can use strain கண்டுபிடிச்சி you can find this strain energy as well. Okay, let's get into a little bit கொஞ்சம் டெக்னிக்கலாக questions பார்க்கலாம். When a mass is suspended from end of a wire, the top end of which is attached to the roof, the lift. Okay, the extension is E. Okay, when the same lift moves up within a constant acceleration of g2, the extension of the wire would be. Okay, ஒன்றும் சொல்ல ஒரு லிஃப்ட்டில் there is a mass m, okay, attached to a wire length L. Okay, this wire, okay, this lift சும்மா இருக்கும்போது the extension is E. Okay, when the lift is going upwards with an acceleration of g/2, அதோட extension எவ்வளோ இருக்குன்னு கேட்குறாங்க. Fine, we know the formula for Young's modulus is F by A into L by del L. Okay, so we know first one E is equal to F by A into L by Y. இது வந்து என்னோட first extension. Okay, second extension force was like force is nothing but mg. Second இதில் கேஸில் வந்து இட்ஸ் ஆக்சிலேட்டிங் அப்வர்ட்ஸ் வித் g/2. ஓகேவா, அப்போது pseudo force கீழே எவ்வளோ இருக்கும், g plus g/2, 3g/2. okay, so then அப்போ வந்து my extension dash will be equal to m into acceleration, which is nothing but 3g/2 into L by ay. Okay, so 3g/2 na 3/2 வெளியே எடுத்துக்கலாம். So my extension E dash will be equal to 3/2 into E. புரியலனா just rewind it a little bit. Okay, yeah, volume கூட multiply பண்ண you will get it entirely. Okay, super. Okay, strain energy வச்சு ஒரு கொஸ்டின் பார்க்கலாம். Yeah, இந்த கொஸ்டின் எடுக்கலாம். Okay, okay. F, இல்லை, this is not based on strain energy. A metal rod of Young's modulus 2 into 10 power 10 Newton per meter square. This is my Young's modulus. Elastic strain 0.02%. They're asking energy stored per unit volume. Direct formula based. Okay, it's nothing but another strain square half into strain square into y. Okay, so it will be half into strain square is nothing but 0.02 divided by 100. Strain square into y is nothing but 2 into 10 power 10. Okay, so it will be like 2 into 10 power minus 2 minus 4, which will be nothing but 4 into 10 power minus 8 into 2 into 10 power 10 into 1 by 2. 400 joules of energy. Okay, okay. Okay, this is a very interesting question. Okay, just see, there is a brass rod. Okay, அதோட length வந்து rod or length வந்து 0.2 meters. Area of cross section வந்து 1 centimeter square. okay, length கொடுத்தாச்சு, area கொடுத்தாச்சு. Young's modulus is 10 power 11 Newton per meter square. Fine. If it's compressed by force applied is equal to 5 kg weight. Kg weight is nothing but 5 into acceleration into gravity. So 5 kg into g is nothing but 150 newtons. Okay. They are asking the change in energy. When 50 newtons of force is used to compress the rod. Yaar question or doubt irka? It's very interesting. See, there are two concepts here. First, there is a rod, okay, அதோட area of crossing கொடுத்துறாங்க, Young's modulus கொடுத்துறாங்க, and it's compressed with something. Okay. It compress ஆறதால it has some strain. The strain இருக்கிறதால there is some energy. So we first find strain, okay, and then find the energy. Or first we or directa we use half into stress square divided by y. Adli only you will get the same thing. Okay. But I made a mistake. Okay. The question என்ன கொடுத்திருக்காங்கன்னா, they ask me the energy, total change in energy, but not per unit volume. So I can't take stress and strain here. So what is the basic thing? Half into F into E. Half into F into E. Okay. When I'm compressing, so it will be half into, my F is nothing but 50. I should find E. E எப்படி கண்டுபிடிப்பேன்? Young's modulus. F L by A E. AY equals to E. 50 into length is 0.2 divided by 1 into 10 power minus 4 into 10 power 11 equals to E. Solve this. Okay. 2.5 into 10 power minus 5 joules. Okay. Fine. So when I compress it, okay, now this is the change in energy. This thing everyone can find. Okay. And if a question is, what is the change in energy? Is there an increase or decrease? So no one's okay. Yaro solla. Is it an increase or a decrease? Okay. Just imagine the rod is being compressed. Okay, wow. Back to the first. Yeah. When compressed, the distance between atoms reduces. So when the distance between atoms reduces, the potential energy spikes. Okay. So when you compress it, the potential energy increases. Okay. So yeah, inga vande the energy increases. Paka? Clear? Everyone? Okay. So, ஒரு டாபிக் முடிஞ்சு. There is a bulk modulus of there is a spheric ஒரு sphereோட bulk modulus is B. Okay. And the bulk modulus and the change in pressure is P. Okay. I have to find the ratio of change in radius to initial radius because of the pressure. Okay, very simple. See, bulk modulus is nothing but pressure divided by change in volume by initial volume. Okay, Paka. This is how we derive this equation. Okay, if instead of volume I have to find radius na. Volume is nothing but r cubed varma for sphere. So it will be nothing but del P by V is equal to 3 del R by R. So del R by R is nothing but del P by 3B. Paka. Okay guys, I think இதுக்கு இவ்வளோ போதும் sufficient நினைக்கிறேன். So yeah, we have solved on some 5-6 questions, 15-20 questions இருக்கும் from all the lower questions எல்லாம். But yeah, so let's finish the lecturing. This is okay. Let's finish the lecture. If you have any doubts, ask me in the comment section. Okay, after the video gets over, I will reply to you. Okay. Yeah, guys. All right, everyone. Take care. Bye. Oh, Poisson's ratio. I forgot. Okay, Poisson's ratio. Did I forgot? நான் சொல்லி கொடுத்தேன்ல இல்லையா? Poisson, I covered everything. Thermal stress, elongation due to the own weight, bulk modulus. Okay, simple only. Poisson's ratio. Oh, I didn't mention. Oh, I'm so sorry. Okay, guys. I forgot about Poisson's ratio. Okay, thank you so much. Thank you so much for reminding me. Okay, there is another topic. Okay, this is also simple. Nothing much. Okay, there's a ratio. Okay, this Poisson's ratio is also another ratio. See, when you expand, see, when same again the same example, when you expand something, okay, there is a longitudinal increase in its length and a lateral decrease in its radius. Correct? When I increase a rod's length, volume, since volume is constant, நான் இன்க்ரீஸ் பண்ணும்போது இதோட லென்த் கெட்ஸ் இன்க்ரீஸ் அண்ட் திக்னஸ் கெட்ஸ் டிக்ரீஸ். கரெக்டாக? ஸோ அந்த அந்த ரெண்டோட சேஞ்சை வச்சு இன்வால்வ் பண்ணுற ஒரு ரேஷியோ தான் வந்து மை பாய்சன்ஸ் ரேஷியோ. ஓகே, இட்ஸ் சிம்பிள். இட்ஸ் மை okay. This is so bad. நான் மிஸ் பண்ணிருக்கூட இந்த டாப்பிக்கை. பட் சின்ஸ் there aren't any significant questions from this, they might still ask, but there aren't very significant questions coming from this topic, but still okay, it's required. படிச்சாகணும். Okay, Poisson's ratio is simple. Okay, you have lateral strain by longitudinal strain. Okay, lateral strain is nothing but change in radius or diameter by initial diameter divided by change in length by initial length. This is my Poisson's ratio represented by this symbol sigma. Okay, so yeah, I'll give you an example. Now I'm looking for a question. So do I have it? No. Okay, I'll try to frame a question இப்போ. Before that, this Poisson's ratio, you can include it in, you can include volume in this as well. Okay, say my volume is equal to pi r square into L for a rod. Okay, so இதில் வந்து del V by B is equal to del 2 del R by R in plus del L by L. Okay, we know that del R by R minus del R by R, because length increase ஆகும்போது radius decreases. From this we know del R by R minus is equal to Poisson's ratio into del L by L. Okay, so I can write technically I can write it as 2 into minus 2 into sigma into del L by L plus del L by L. Okay, so இதை simplify பண்ணும்போது you'll get 1 minus 2 sigma into del L by L. Okay, this is your change in volume by initial volume, Poisson's ratio வச்சு. ஓகே, பக்கா. எப்படி கொஷின்ஸ் கேட்கலாம்? Say longitudinal. Okay, in the equation itself I'll give you one question. Okay, Poisson's ratio வந்து usually it's between -1 இருந்து 0.5 வரைக்கும் தான் இருக்கும். ஓகே, okay, fine. இப்போ வந்து say there is a wire. Okay, I am increasing its length. The length வந்து increased by 1% வச்சுக்கோ. Okay, length less strain 1%. Say Poisson's ratio of that to be 0.3. Okay, now I'm supposed to find the change in its volume. Okay, using this formula I know that change in its volume by initial volume is equal to 1 minus 2 sigma, which is nothing but 2 into 0.3 into del L by L. 1 minus 0.4 into 1% nothing but 1 by 100. So 0.4 is nothing but 4 by 10. So it's 4 into 10 power minus 3 or 0.4 percentage change. Okay. Now you can see here when Poisson's ratio it's equal to 0.5 now, in the 2 into 0.5 will come 1. Okay, so 1 minus 1 is 0. So there won't be change in volume. Okay, so theoretically it can't be greater than, you can't increase the length and have the volume increase as well. Okay, it's not possible. அதனால Poisson's ratio is between -1 to -1 இருக்கும் என்ன இருக்கும் -1 will become 3 times. Yeah, it's between 0.5 இருந்தா it won't have any change in volume, but it's not possible. Okay. வேற என்ன மாதிரி கேட்கலாம் Poisson's ratio? I think this is the only model of question I can come up with இப்போ. I don't have questions for Poisson because questions பார்த்து they didn't have this topic. Okay, fine. Thank you for reminding me, Safura, the only person who has been active the entire class. Okay, done. Have I covered all the topics? Poisson's ratio, bulk modulus, rigidity modulus, Young's modulus, Hooke's law, elasticity, starting theory, strain, stress energy, some graphs. Okay, I think அதான் முடிஞ்சு. Yeah, இதுக்கு மேலே I don't think there is anything left. Yep. Okay, so yeah guys, that is mechanical properties of solids for you, a very simple chapter. And this is me, Rihan, again. Okay, this will be uploaded in the app. நாங்க upload பண்ணிடுவோம். I'll send it to the admin and he'll upload it. So yeah, thank you so much for staying live. Yeah, bye bye. Thank you guys, thank you so much.